Hi students, welcome to the problem solving session on source free RL circuit. Let us see this problem. In the circuit shown in figure, find R value for which the steady state energy stored in the inductor will be 1 joule. So what we have to find R, the energy stored in the inductor is 1 joule. That is this R we have to find. So for they have given energy stored in the inductor. So energy stored in the inductor is W is equal to 1 by 2 Li squared is equal to 1 joule they have given. Okay. So what are the things we have in this formula? L we have. L is equal to 2 Henry. What we need is I. Fine. So if I find L and I, from that we can find R value. Okay. So I want to find what is the current flowing through this what you call circuit. Okay. So now let us solve this problem. Okay. Now if I want to find the current flowing through this circuit, what I do is the current flowing through this inductor because energy stored in the inductor. This current only I want. Okay, if I want to find that, I make it as a simple circuit by using Thevenin's theorem. Right? So what I am going to do is I convert this big circuit, right, into simple circuit. What is that? The equivalent circuit will be, we know it is, if you have a voltage source and resistor, I can replace with Thevenin's voltage and equivalent resistance called Thevenin's resistance, right? This 2 Henry. Yes or no? So I want to convert this into this. Okay, V Thevenin I have to find, right? So what is from this I can find I value. Yes or no? Because I is equal to Vth by Rth. Once I find I can find R value. So that is the logic I am going to use. So current through the inductor only I want. Okay. So what is I? We will find it. From this diagram we know V Thevenin is equal to, you see, V Thevenin is voltage across this terminal. Let us assume this is terminal A and B. So the voltage across this terminal A and B. So that is given by, because this is the current I want to find. So I consider this is a load. So what is this? It is total voltage. I apply voltage divider formula, 60 into the same resistance divided by total resistance, 80 plus 40. Yes or no? This one. Okay. So what is the thing I am getting is, from here I got V Thevenin is equal to 40 volt. Right? In order to find R Thevenin, what I need to do? In order to find R Thevenin, I replace voltage source with short circuit, current source with open circuit. This is like this. This is the circuit, right? 40, 80. So I find R Thevenin. R Thevenin is given by, what is that? These two are parallel. So 80 parallel 40. That must be in series with R. So this will give what you call 80 by 3 plus R. This is R Thevenin. So I got V Thevenin by R Thevenin. So what is I? I is Vth by R. Vth is 40. R is 80 by 3 plus R. Now we got I. So W is equal to half Li square. So 1 by 2, L is 2 Henry, I is 40 by 80 by 3 plus R, half Li squared. That is what energy stored, that is equal to 1 joule. If I simplify this, what I get is, from this I can find R value. I will find R as 13.33 ohm. Simple problem. Okay, next. Find I and Vx in the circuit shown in figure. Assume I naught is equal to 2 ampere. Okay. So what is the thing I have to find? I have to find this I and Vx. Okay. So what is this? Is, you see, this is a RL circuit, source free. So the circuit is source free RL circuit. Right, for source free RL circuit, what is the current flowing through the circuit? I is equal to I naught e power minus R by L into T. I naught they have given 2 ampere. L is 2 Henry. What is the only thing I have to find? R value. Right, so if I find R value, then from this I can find what is I value. Right, this is the logic. Okay, how can we find R? R is the, we know it is a Thevenin's equivalent resistance. So we have to find the Thevenin's equivalent resistance for this circuit. In order to find the Thevenin's equivalent for the circuit containing dependent source, this is dependent source. What we need to do, we have to replace the terminal where we want to find the current, right, with the equivalent voltage source or current source. Either we replace with the equivalent voltage source of 1 volt or current source of 1 ampere. From this voltage source you find I naught, or from this current source you find V naught. Then V naught by I naught will give R Thevenin. This is the logic we know. So we apply the same logic. So first what we do, we replace this inductor terminal by voltage source. You can replace by current source also, but I replace by voltage source with 1 volt. Right? So I replace the terminal. What is the thing? Because of the presence of what you call dependent source, I replace like this. This is 1 ohm Vx plus minus. Then this one 2 ohm. This and this is coming like this, plus minus 2Vx this is 6 ohm, right? Okay, now what we have to find, this is V naught. So from this we have to find I naught. R Thevenin is equal to V naught by I naught. That is the logic. So what is R Thevenin? R Thevenin is equal to V naught by I naught. V naught is equal to 1 volt. So as to what I have to find I naught. Okay, so I apply KVL as usual. Let us assume this is current flowing through this terminal. Loop is I1. This through this loop is I2. Right? Okay. Now I write KVL for loop 1. For loop 1, KVL is total resistance here is 2 plus 1 3. So 3I1. This 2 is common, so common to loop 1 and 2, so that is 2I2. And here we have two source. Here the I1 is coming, entering through positive terminal because it is coming like this. So plus 1, here entering through negative terminal. So it is minus 2Vx. I1 is entering through negative terminal, so I put 2 minus 2Vx equal to 0. Right? Okay. Next. So what we do? Okay. Next, this is equation number 1. Let us assume. Similarly, for loop 2, what happens? For loop 2, it is total is 8. So 8 ohms. So 8I2. 2 is common. So minus 2I1. And here for this voltage source, the current is entering this via this. So positive terminal. So it is plus 2Vx. Right? So plus 2Vx equal to 0. Then we have a three variables. So I want to make it as 2 variable because for getting 2 current I need 2. So 2 equation I have. So I need only 2 variable. From this we can understand Vx is equal to minus I1 because I1 is coming from here to here. It is coming entering via this. So what is my Vx? Vx equal to I into R. I is coming to the negative terminal. So minus I. R is 1. So Vx equal to minus I. I substitute Vx equal to minus I here. So it will become 3I1 minus 2I2 plus 1. Vx equal to minus I. So it is plus 2I1 is equal to 0. This indicates 5I1 minus 2i2 equal to minus 1. This is equation number 3. Similarly, here 8i2 minus 2i1 plus 2 Vx is equal to minus i1. So minus 2i1 is equal to 0. This implies 2i2 minus i1 is equal to 0, right? So this is equation number 4. From this, if you simplify equation 3 and 4, what you get is I1 is equal to minus 1 by 4 ampere, right? So what I need is I0. What is the relationship between I0 and I1? I0 is going in this direction, I1 is coming in this direction. So I0 is equal to minus I1. So this implies I0 is equal to minus I1. So that is 1 by 4 ampere. Right? Okay. So what is the thing? R Thevenin is equal to V0. V0 is 1. I0 is 1 by 4. This is 4 ohm. Now we got everything. So what is my I of t? I of t is equal to I0, 2 ampere, e power minus R. R is 4. L is 2. In the problem they have given t. So 2 into minus 2t ampere. We found I. Right, so what they ask is we have to find Vx also. I we find, right, what is Vx, right? I is coming in this direction. This is the I direction, so it is coming in this. So from this, Vx is equal to minus I into R. R is 1 ohm. I is minus 2 into e power minus 2t. I is 2 into e power minus 2t. So V is equal to minus Vx is equal to minus 2 into minus 2 e power minus 2t volt. I think this is a simple problem but somewhat critical. Hope you understand this. If you have any doubt, please ask me in comment section. I will clarify. Thank you.